this video focuses on the intermediate value theorem. You can go ahead and read this orange box on the intermediate value theorem, but I do think when I go through this example, it'll become a little bit more clear for you. So just take a moment, pause, read the orange definition. Here's the example. Show that the function f of x, which is a cubic function, has one solution of an x-intercept. So we're going to start off by just evaluating the function. We're going to substitute a number in for x. So I'm going to evaluate it for f of negative 1. So I'm going to replace this x with a negative 1 and this x with a negative 1. So I get negative 1 cubed plus negative 1 squared plus 1. Negative 1 times negative 1 times negative 1 is negative 1. And then over here, negative 1 plus negative 1 is 1, and then plus 1. When we're done, we get a value of 1. So f of negative 1 represents an ordered pair. So this is our first point on our graph, negative 1, 1. Now let's find another point, f of negative 2. So I'm going to substitute negative 2 now in for x. So I can say negative 2 cubed plus negative 2 squared plus 1. And I simplify that. Negative 2 times negative 2 times negative 2 is negative 8 plus negative 2 times negative 2 is 4 plus 1. Negative 8 plus 4 is negative 4. Plus 1 is negative 3. So f of negative 2 is negative 3, which is a second point on our graph. So now let's take and graph these two ordered pairs. So my first ordered pair is negative 1, positive 1. So I'm going to just go by 2's here. So negative 1, negative 2, negative 3, 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3. So our first order pair we'll graph is that red one, negative 1, positive 1. So left 1, up 1. Then our second order pair is negative 2, negative 3. And then this is our interval. So if we say that we have a function back in this intermediate value theorem from negative 1 to negative 2, negative 2 to negative 1, got to put them smallest to largest, negative 2 to negative 1. Notice there's a value c in between them that the function will equal 0. Because we're changing signs. If I graph these two ordered pairs and connect, somewhere between here, there has to be an x-intercept. I'm not sure what exactly it is, but it's in between there. There must be a 0 in the function because we're changing signs. From negative 1, negative 2, we go from a 1 to a negative 3. So there is a function there. There is a 0 in the function, there is an x-intercept. We change signs.